Welcome all. In this video we are going to create the pulley support assembly in Creo. So this is the exploded view of the pulley support assembly, and there are 7 parts in the pulley support assembly. So first one is this bracket, then second one is this nut, third is the bushing, fourth is the pulley, fifth part is the washer, sixth part is this turn screw, and seventh part is this cap screw. So one by one we'll start by creating the individual parts and then we will assemble them together. We'll start with the bracket, which will be our base part, on which one by one we will add the other parts. So then this is the drawing of the bracket, this is the front view, and this is the left hand side view. So to create this bracket, let us start by creating the file. Let us name it as bracket. Let us go to the right hand side view, select extrude, placement, define, and select this right plane. Go to sketch. This is the cross section, the height is 42.5 and this is 31.25. So we'll create a line. This is 42.5 and this horizontal line, this is 31.25. Now the thickness is 1.25 here and 1.25 here. So to do that, we will use this offset tool and specify the thickness 1.25. Close these two ends and delete these two segments. So our geometry is ready to be extruded. Say done. From the left side view, this distance is 20, that is this distance is 20. So specify this as 20. So we have created our drawing in the right plane and extruded in this direction. Instead, we are going to extrude on both sides of the sketch plane and say done. Next, we want to create this flange like structure. The dimensions are, this is 5 and this is also 5. So this can be done again by extrude, select this face and say sketch. Select the use tool, select this edge and this edge. Now select the offset tool. We know this distance, it is 5 and this distance is 5. I'm entering the value as -5 because of the direction of the arrow. Next, join these two corners and these two corners and delete these two segments. Say done. Select the direction and specify the thickness again 1.25. Say done. Next, we want to create this rib like structure. This will be done again either using the rib tool, that is this profile rib, or this can be done using the extrude tool. Let us see how it can be done using the extrude tool. select extrude, placement, define, and select this inner surface. Say sketch. Now go to sketch, select references, select this face, select this face, so you can see reference line has been generated. Again go to the sketch orientation. Now this line, it starts from this corner point and it ends at a distance 27.5 from this inner surface. We'll need one more reference line for this surface, that is the top surface. Again go back to sketch orientation and starting from this point, draw a line on this reference line. Now the distance given between this line and this point is 27.5. So specify this distance 27.5. Then close the section. So our geometry is ready to be extruded. Say done and specify the thickness 1.25. So this is done. We want to create exactly these two features on this side also. We will select them using the control button, group them, and using the mirror tool, first select this group, select the mirror tool and select this mid plane and say done. Next, we want to create this part of the bracket, that is this part. Now its thickness given is 5, but this thickness is from the back surface. From the front surface it would be 5 minus 1.25. So depending on which surface you select to create the geometry, you will have to provide the thickness for extruding. So go to extrude, placement, define. You will select this front surface and say sketch. Go to sketch, references, select this top surface. It will create a reference line in our sketch plane. Select this mid plane and say OK. Let us create a center line. Now create a rectangle. It should be symmetric about our vertical center line. This distance is 5. This width is 7.5. This height is 22.5. Next, we'll create a circle. There are two circles which represent the holes. So the diameter of the circle is 2.5 and it is located at a distance 7.5 from the top edge. There is another circle here of same dimension and the distance between these two circles is 10. So provide this distance as 10. select done. Now thickness will be 5 minus 1.25 and say done. But we still have not created the through holes. To create the through holes, again go to extrude, placement, define. So there are no through holes present. Select this surface, then use the use tool, select this edge of the circle and these two edges of the other circle. So we have created the geometry. Say done. Reverse the direction, and to provide the depth, select this surface. Select the remove material option and say done. So now we have got the through holes. So with this we have created the first part, which is the bracket. Let us save this file and then close it. The next part is this pulley. To create the pulley, we will create the pulley. As you can see, this is the, we have selected this, we have to select the front plane to create the pulley. So create new file for pulley. Go to extrude, select the front plane and say sketch. The outer diameter of the pulley is 30 and the inner diameter is 11.25. Say done. The thickness of the pulley is 10. And we have created the drawing in front plane and extruded in the front direction. To use the symmetry, we are going to use extrude on both surfaces. Say done. Now in order to create this groove, we'll use the revolve tool. So select revolve, placement, define. Now you can select either the right plane or you can select the top plane. Say sketch. We know for using revolve tool we need a geometry center line, so create this geometry center line, and for using the symmetry we are going to use this center line. Go to sketch, references and select this edge. Now create a line which will be symmetric about this center line, which is shown by these two arrows. This distance is 2.5, this distance is 2.5, that is total is 5, and 10 minus 5 is 5. That means this distance is 5. Using a line tool, join these two edges such that it is a triangle, and then the included angle is 45 degree. So provide this included angle is 45 and say OK and done. Now if you want to remove the material, select remove material and say done. So with this, our second part, that is pulley, is complete. Now save the file and close the file. Next part is this bushing. Select extrude, placement, define select this front plane and say sketch. So we'll create this cylinder first. The diameter is 11.25 and the length is 20. So create a circle of diameter 11.25 and length is 20. Next, we'll create this cylindrical part or disc-like part. Its thickness is 2.5 and diameter is 15. Say extrude. So the diameter is 15 and the thickness is 2.5. And then we'll create this cylindrical part. So the remaining thickness is 31.25 minus 2.5 minus 25 and its diameter is 11.25. So now we'll select this surface and then on that surface we are going to draw a circle of diameter 11.25. Say done. The thickness will be 31.25 minus 2.5 and minus 20, which will be 8.75. Now inside this part we have a through hole, but these two holes are having different diameters. So to do that we can use the hole tool or we can use the extrude tool using the remove material option. So select hole, select this surface, this distance is 0 and similarly the distance from this plane of the center is also 0. So now the center is exactly concentric with the axis of the cylindrical part. Now we want a standard hole profile and in that we want a counter bore hole. So here we can specify the depth of hole. It's a through hole. So select this surface. Now then the profile of the hole. So the smaller diameter is 2.5. This is 2.5 and the larger diameter is 3.75. This distance or the depth of this hole or the larger hole is 21.75. So we have specified all the parameters of the hole. Say done. So with this our bushing part is complete. Save this and close the file. Now the next part is the washer. Say extrude, define the front plane and then draw two circles. Diameter of the outer circle is 15 and the diameter of the hole is 3.75, represented by the smaller circle. Say done. The thickness is 1. Say done. Save this file and close it. Now next part is the nut. Create a new file for nut. Go to extrude, placement, select the front plane. Using the palette tool, select hexagon. You drag it using your mouse pointer or the left click and place it at the center. Close this. Using the normal, specify the distance between this two parallel edges as 4.3. So select this edge and this edge. Press the middle mouse button. Delete the previous constraint and specify the new dimension 4.3. There is inner hole which is of diameter 2.5. So draw a circle, specify the diameter as 2.5. Now say done. This thickness is 3. So specify this 3. And extrude on both sides of the sketch plane. Say done. Now we want to create this chamfers. So to do so, use the revolve tool. Select this right plane which is passing through one of these edges. Go to sketch. Create a geometry center line, as we have to use the revolve tool. Now go to sketch, references, select this top surface and this surface here. Create a triangle in this way and say done. Select the remove tool or remove material option and press done. So we have created the chamfers on one side. We want chamfers on the other side. Now we can use the symmetry. So select this revolve feature, select the mirror tool and then select the front plane and say done. Save this file and close this. Next part is this cap screw. There is this screw. Select extrude, placement, define and select the front plane. So this diameter is 3.75. Create a circle. and then okay. So instead of doing this, we'll first create the head of the screw, because it would be more convenient as we can use the reference plane for mirroring the chamfer. So again, select extrude, placement, define, select the front plane and go to sketch. Use palette, select hexagon and place it at the center. This distance is 8 and the thickness is 6. Select extrude on both surfaces or sides of the sketch plane and say done. So we want to create the chamfer. Select revolve, placement, define, select the right plane and say sketch. Now draw the geometry center line. Go to sketch, references, select this top surface and this surface. Say done. Say remove material and say done. We want same chamfer on this sides of the front plane. Use the mirror tool. Select the front plane. Say done. Now on this side or back side of this head, we want this threaded part. Its length is 27.25 minus 6, that is 21.25, and diameter is 3.75. So say extrude, or we can select extrude on this side and then extrude the total distance. We'll select this plane itself, say sketch, and then create a circle. The diameter is 3.75. Say done. Flip the direction and specify the distance 27.25. That is this total distance from this surface to this, 27.25. Say done. Let us save this file and close it. And the last part remaining is the turn screw. Create a new file. Extrude. Select the front plane and say sketch. Using the palette tool, create a hexagon and say done. So this distance is 16 and the thickness is 3.75. Say 3.75 and extrude on both sides. Say done. Again, we have to create the chamfers. So in this case, we are going to select the plane which is passing through corner instead of a plane which is passing through the side. Say revolve and select this top plane. Go to sketch, references, draw a triangle in this way. The geometry should be closed, and to use the revolve tool we need a geometry center line. Say done, say remove material and say apply. We want exactly same chamfer on the other side, so select this revolve, mirror tool and select this plane. Say done. Our hexagonal head is ready. Now this cylindrical part, diameter is 2.5 and this length is 33.75 minus this 3.75, that is 33. Sorry, that is 30. So go to extrude, placement. Now select this surface, go to sketch. So now the diameter is 2.5 and this length is 30. Say done. Now save this file and close the file. Now next we want to create this assembly. So create new file for assembly, select assembly design, our base part will be the bracket, so add the bracket using assemble, say open, there is no constraints, select default, now it is fully constrained, say done. Next part is this nut. Now we want to align these two axes, go to placement, so align these two axes and select mate, this surface here and this surface. Now it is fully constrained, say done. Next we want another nut on this side, go to assemble, select nut, select open, select the constraint, select this axis and select this axis here. New constraint, mate, this surface and this surface. So now it is fully constrained, say done. Next we want to assemble this bushing, select the bushing, select the first constraint, align, select this axis and this axis. Select the second constraint, which is mate, select this surface and select this surface. Fully constrained, say done. Next part is this pulley. Say assemble, pulley, go to placement. First constraint is align, select this axis and select this axis. Next constraint is mate, select this surface and select this surface. So we have made a mistake. We want this surface of the pulley to be assembled with this surface. So this is done. Now this is fully constrained. Say done. The next part is this washer. Go to assemble, add the washer, go to placement, go to align, select this axis and select this axis. Go to move it in front. Now go to placement, add new constraint, select this surface and select this surface of the pulley. Now it is fully constrained. Say done. Next we want to add this cap screw. Go to assemble, select the cap screw, select align, select this axis and select this axis. Add new constraint, which is mate. Now select this surface of the washer and select this surface of the screw. Now it is fully constrained. Say done. Next part is this turn screw. Go to assemble, select the turn screw, go to placement, select this constraint, align, select this axis and this axis. Add a new constraint, mate, select this surface of the nut and select this surface of the nut. Now it is fully constrained and say done. So this is the final assembly of the pulley support. Thank you.